Welcome back, everyone. I forgot to include in the previous video examples looking at inverse functions because I saw that I mentioned it here, but I didn't look at it. So if you just finished the previous video, just look at this next one here. I'll just call it part 2. So you can have a look at inverse functions. So if you're dealing with inverse functions, we'll look at mainly those 3. So the derivative of the sine inverse of f of x, right? That's the general form. And the rule tells us that that derivative is just equal to the derivative of f of x, right? Divided by the square root, right? Of 1 minus f of x squared. So that's the general that's the general form, right? And obviously, like we mentioned before, this can apply to any f of x. Okay, so if you have the special case where now where sine, well, rather f of x is equal to x, then you will have sine inverse of x is just equal to the derivative of x, which is 1, right? 1 divided by the square root of 1 minus x squared, right? So that's for the special case of sine inverse of f of x. Oh, sorry, of x. So now if you're looking at the derivative of the inverse cosine of f of x, then this is just equal to more or less the same as the sine inverse, but now you add a negative sign at the front there. Right? So, and once again, if you have the special case of, let's say that you're dealing with cos inverse of x, and you're trying to find that derivative, it's just going to be equal to minus x, right, in the numerator, divided by the square root of 1 minus x squared, right? So that's for the special case of cos inverse of x, right? So if you're looking at tan inverse now, so if you have tan inverse, the rule tells us that that is equal to the derivative of f of x, but now divided by 1 minus f of x squared. This is, sorry, not minus, but rather 1 plus. Yeah, 1 plus f squared of x, right? So that's the general form for tan inverse. Sorry, I forgot to erase this. This should not be there. Right? So that's the general form for tan inverse of f of x. And if you're looking at the special case where x is equal to, sorry, f of x is equal to x, then you have tan inverse of f of x is equal to just the derivative of x, which is 1, divided by 1 plus f of x squared, which is just x squared, right? So that's for the special case of tan inverse of x. Now, if we wanted to look at one more case, which right, which would be the derivative of cot, right? Cot of f of x. Remember, cot and tan are just related because 1/10 is equal to cot, right? So, But that's for the normal trigonometric functions. If you're looking at inverse functions and you're trying to find the derivative of cot inverse of f of x, right? That is just equal to almost the same as tan inverse, but now there's a minus at the front there. And if you're looking at the special case where again f of x is equal to x, then you have cot inverse of x is just equal to minus the derivative of x, which is 1, divided by 1 plus f of x squared, which is just x squared. Okay, so these are the main inverse functions that we'll look at for our problems. So yeah, thank you.